purpose of a local area network is to enable the stations attached to it to communicate with each other. The communication functions that the network provides are performed by a combination of hardware and software components. There are products that have been specifically designed to implement functions defined by IEEE Project 802 for the physical and data link layers of the OSI reference model, and for the functions associated with the higher layers. Many of the functions associated with the physical and data link layers are implemented by 3 physical components. In a typical network, an adapter circuit board is installed in each PC. The board contains the hardware and firmware programming that implements medium access control and physical layer functions. Network devices are interconnected by a cabling system. Attachment units connect devices to a wire or cable which interconnects them to each other. In some local area networks, concentrators are used to interconnect multiple network devices through a central point. This centralization helps simplify network maintenance. Because IEEE standards for these physical components have been widely adopted by vendors, many products are available for CSMA-CD, token ring, and token bus structures. While the lower layers are implemented in hardware and firmware, the functions of the logical link control sublayer and the layers above are implemented in software that runs in network workstations. These software products are network operating systems. Often, one network operating system can be used with more than one lower-level architecture, such as an IEEE 802.3 CSMA-CD or an IEEE 802.5 token ring network. And most network operating systems provide the same categories of functions. A print server facility allows all stations on the network to share printers. Users send output to a remote printer in the same way they would to a printer directly attached to their own stations. Print queues allow users to send output even if the printer is in use, and they also allow certain jobs to be scheduled ahead of others, depending on the print priorities that are established. The disk and file server facility allows stations to share disk storage. A station can be assigned a specific area on the server's disk to use as a disk drive or as a subdirectory. When users make I/O requests, the requests are redirected to the disk or file server and processed there. But the transference of data across the network is transparent to users. Applications can share access to the same file, but the applications are responsible for maintaining file integrity using facilities of the operating system like access rights, sharing rights, and record locking. An electronic mail function allows users to send, receive, and store messages and documents. A message may be sent to one user, a group of users, or all users on the network. Another function most network operating systems provide is name translation. Network users and applications use network names to request services, names that represent users and shared resources. A network name service translates those names into network addresses. A network operating system may also provide various forms of connectivity. One form is remote access, which allows a PC user not attached to a LAN access to LAN services through a telecommunications facility. The communication server is another form of connectivity. This service allows stations on the LAN to access a resource that is not directly connected to the LAN, like a host computer. Network operating systems also offer management facilities that allow network administrators to manage network resources, maintain security, monitor performance, and modify network configurations. In an IBM OS/2 environment, an application server is used to support the sharing of application logic. Because OS/2 is a multitasking operating system, applications can be built that can process requests from multiple network users, allowing the application to be shared across the network. Applications that run in a networking environment may be network transparent or network aware. With network transparent applications, I/O requests issued by an application are redirected to server devices by the network operating system. The redirector interface in the operating system intercepts I/O requests from the application and redirects them across the network. But the application is unaware that they are not being processed locally. This allows an application to use print and file servers even if it is not specifically designed to use them. A network-aware application is specifically designed to invoke and use network services. This is necessary for an application that processes files shared with other applications and needs to use access and sharing rights and record locking to maintain the integrity of the shared data. Networks that support shared application logic usually use a client-server architecture. The client is the portion of the application logic in the user's network station that sends requests. The server is the portion on some other station that processes requests from multiple users. A client-server architecture can also be used with both processes running in the same computer. In a typical mainframe environment, multiple applications can request the services of a system software package, such as a database management system. Here, inter-process communication is based on the client issuing a call. The client passes arguments to the server process, which returns results. For example, the call might represent an SQL select statement. The results are the selected data. In a local area network, this inter-process communication occurs across the network, and the network operating system is responsible for this transport of data. Transport services can be invoked by the client and server in different ways, depending on which application program interfaces the operating system supports. If, for example, it supports the named pipes facility, the client and server processes can create a named pipe. They can then use it to read and write data back and forth by issuing pipe function calls. Or the operating system may support an application program interface like NetBIOS. In this case, each process formats network control blocks and issues NetBIOS commands to transfer data back and forth across the network. Some network operating systems also support the use of remote procedure calls. This means that application processes communicate using calls as though they were running in the same computer. An operating system facility provides the additional logic needed to send data across the network. Unlike named pipes and NetBIOS, applications that use remote procedure calls do not have to be aware that communication across the network is occurring. You have now seen how LAN functions are implemented. Physical and data link layers are implemented by physical components. Network adapter circuit boards, a cabling system, and in some LANs, concentrators that centralize device attachment. Functions associated with the higher layers are implemented by network operating systems. These systems provide functions that allow stations on the network to share resources and to create, store, send, and receive messages. And in some cases, they provide remote access and communication server functions. Networks that support the sharing of application logic use a client-server architecture. Data is transported across the LAN by the Network Operating System Transport Services, which might be invoked using a named pipes facility, an application program interface like NetBIOS, or remote procedure calls. Please turn to Mini Course 1 in your personal reference guide and continue your study.